In math, getting the right answer is pretty much everything. But how do we guarantee that the right answer is the same for everyone, no matter how they tackle a problem? Well, the secret is a universal rulebook called the Order of Operations. Let's dive into why it's so incredibly important.
All right, take a look at this. It seems simple, right? Just 2 plus 3 times 4. But depending on the order you do things, you can get two completely different answers. So which one is it? Is the answer 20 or is it 14? This little problem right here is the perfect example of why we desperately need a clear set of rules.
And here's exactly how that happens. If you just read it from left to right, you do 2 plus 3, which is 5, and then multiply that by 4 to get 20. Simple enough. But what if you multiply first? Well, 3 times 4 is 12, and then you add the 2, which gives you 14. See that? Two totally different answers from the exact same numbers. That is just pure mathematical chaos.
So how in the world do we fix this mess? We need a rulebook, a single, universal standard that every single person agrees on. That way, no matter who's solving the problem or where they are in the world, they always get to the same correct answer.
Because without this shared rulebook, things can literally fall apart. Just imagine engineers trying to build a bridge or programmers writing code for an app. If their most basic calculations could be interpreted in two different ways, well, the result would be a total disaster. We absolutely have to have one correct answer every single time.
And that rulebook has a name. It's called PEMDAS. The best way to think about it is like the official grammar of mathematics. It's this elegant solution that brings order to all the potential chaos and makes sure every calculation is done the exact same way.
So let's break this acronym down. At the very top of the hierarchy, we have P for parentheses. Anything inside parentheses is a VIP. It gets solved first, no questions asked. Next up, we've got E for exponents. Then we hit a pair, M and D for multiplication and division. And finally at the bottom, another pair, A and S for addition and subtraction. You always work your way down this list.
Now this next part is maybe the most important and most often forgotten part of PEMDAS. See how multiplication and division are on the same level? They're like a team. Same thing goes for addition and subtraction. This means they have equal priority. So if you have both in an equation, you don't automatically do multiplication first just because M comes before D. You simply work from left to right, handling whichever one pops up first.
All right, that's enough theory. The absolute best way to really get the stuff is to see it in action. So let's walk through a few examples together, starting off nice and easy and then cranking up the complexity.
Let's kick things off with a basic one. 8 plus 2 times 5. Okay, let's check our PEMDAS rules. We know multiplication comes way before addition, so our very first step is to solve 2 times 5. That gets us 10. Now we can do the easy part. 8 plus our new number, 10, equals 18. See? Simple, clean, and one correct answer.
Okay, let's level up a bit. This problem's got an exponent, multiplication, subtraction, and addition. So where on earth do we start? Well, PEMDAS tells us exponents get top priority, so 3 squared is 9. Now our problem reads 9 minus 4 times 2 plus 1. Next up on the list, multiplication. 4 times 2 is 8. So now we're just left with 9 minus 8 plus 1. And since subtraction and addition are on that same level, we just go left to right. 9 minus 8 is 1, and finally, 1 plus 1 equals 2. Done.
And now for the final boss. This one's got everything, including those VIPs, parentheses. And what does the P in PEMDAS tell us? Parentheses are king. They always go first. So first thing we do is solve 8 plus 2, which is 10. All right, what's next? The exponent. 3 squared is 9. Okay, our problem now looks like this. 10 times 5 minus 9. Multiplication is next, so 10 times 5 is 50. And our final, easy step, 50 minus 9 is 41. That's the power of parentheses. They can completely change the game.
Okay, so we've seen how to use the rules. But it's just as important to know about the common traps that people fall into. So let's look at the absolute biggest PEMDAS mistake so you can make sure you never, ever make it.
This is probably the #1 mistake people make, hands down. Someone looks at the acronym PEMDS and thinks, well, M comes before D, so I have to multiply before I divide, right? So they solve 4 times 3 first to get 12. Then they do 12 divided by 12, and they get 1, which is totally wrong.
And here's exactly why that's wrong. Remember that same level rule?
Multiplication and division are equals. They have the exact same priority. So when you see both of them in a problem, you just solve from left to right. The correct way is to do 12 divided by 4 first, which gives you 3. Then you multiply that by 3 to get the correct answer, 9.
So why does any of this matter? I mean, really? Well, because PEMDAS isn't just some random rule for math class. It's a fundamental principle that's working hard behind the scenes in the technology you use every single day.
You know, if you've ever used a spreadsheet program like Excel or Google Sheets, you've used PEMDAS without even realizing it. Imagine you type this exact formula into a cell, equals 10 plus 2 asterisk 5. What do you think is going to happen when you hit enter?
The answer is 20. It will be 20 every single time. And why is that? Because the software itself is programmed with the order of operations. It knows it must do the multiplication first. That's 2 times 5 is 10. And then add that to the original 10. If the computer just went left to right, it would get 60. A totally wrong answer that could destroy an entire financial report.
And this is absolutely crucial for so many professions. Accountants, data scientists, engineers. I mean, pretty much anyone who uses a spreadsheet to make important decisions is relying on this fundamental rule. Their entire job depends on computers that follow the order of operations perfectly, every time, to make sure their results are accurate and trustworthy.
So in the end, you see, PEMDAS is so much more than just a math rule. It's a global agreement, a kind of shared language for logic that brings order and consistency to what could be a really chaotic world of numbers. Which kind of leads to a bigger question, right? What other unspoken rules, maybe on the road or in conversations or online, bring that same kind of predictable order to our lives? That's something to think about.